Hello everyone, welcome back to Alkaline Hydroxide 784. I'm actually re-recording it because I kind of feel like I messed up the first time around, so yeah, I don't want to sound super incoherent this time. Okay, so for the TDBTP, today I'm going to talk about the chemistry paper 2, which in my opinion is definitely different from chemistry paper 3 in terms of structure. Even though the content that you had to revise is still the same, there will be slightly different stuff tested in the paper 2 and paper 3 in terms of the proportion. And if you look at it that way, paper 2 tends to have a lot of explanation questions, and paper 3 tends to have the elucidation questions. And in paper 2, you realize that you cannot really choose your questions. You had to just do every question in the paper. I mean, you could choose not to do the question, but that means you lose your marks. So yeah, so yeah, I had to do all the questions in the paper. And paper 2 seems like tends to have a lot of explanation questions because I don't know, that's just how they set the paper. I think it's because paper 3 has a choice, so they try to make the questions similar in what you can see. So they tend to use a lot of the elucidation or short answer questions for that. Whereas for paper 2, they can do whatever they want, so they just put in a lot of explanation questions and annoy all of you. So yeah, have fun. So actually the thing about explanation questions is that some of you might find it hard to memorize it, but that means you're doing it in a wrong way. Like if you try to memorize it word for word, you will never really like memorize all of the explanations unless you're really good at memorization. But if you memorize the keywords and also understand the explanation, understand why the process works, then you will be able to do it relatively easily. Like for example, if you were to actually this is what I messed up earlier trying to give explanation. Sorry. If you have your periodic table right in front of you, sometimes that may help when you're doing an explanation. So you just stare at the periodic table and look at the numbers, you can get an idea. Or if you don't have any faith in yourself, you can always go to the table with the the ionic sizes and all that. You can look at that if you need to, just in case you forgot which one is bigger than the other. Or if you just feel unsure of yourself no matter what, you can just look at it just to confirm your thoughts. Yeah. So like for example, if as I meant, I actually told this at the very beginning of the previous recording, but the thing is, you should look at exceptions as well, because even though there are many trends, there's always going to be exceptions to the trend, and that's true in chemistry as well. So if you look at the I believe it's the beryllium, boron, magnesium, aluminium, that section, as well as nitrogen, oxygen, phosphorus, sulfur. So that's the place where the exceptions tend to happen. So like for example, if you were to look at a normal description, maybe you want to go to sodium and magnesium first of all. You know that magnesium and sodium are in the same period 3, and magnesium has one more proton than sodium. So if they're in the same period, the electron shielding is similar because they have the same number of orbitals to some extent. But magnesium has one more proton than sodium as well as one more electron if you think about it. So in a way, there's more attraction from the protons, like the nuclear attraction is stronger, and therefore the atomic radius of magnesium will be a bit smaller than that of sodium. And likewise, if you look at magnesium and aluminium, magnesium if you go from magnesium to aluminium, you're going from the S to the P, and in that scenario, the electron in the P is like 3p is it 3p? Yeah, 1s, 2s, 2p, 3s, 3p. Yeah, 3p. One electron is of a higher energy, so it will make aluminium's radius a little bit larger because the electron is in a different orbital, not like the overall orbital, but like the p orbital rather than the if you think about it in that way. So aluminium actually has a slightly bigger atomic radius than magnesium. As for the nitrogen oxygen, that one is due to the oxygen having paired electrons, which increases inter-electronic repulsion, and therefore oxygen has a slightly larger atomic radius than nitrogen. So yeah, you can use that for so if you have the intuition, you can explain it very quickly, and just memorize the exceptions, and for in general you will have a good intuition of how to explain everything. And sometimes they will ask you to explain it with regards to the ions. So if for example you were to compare Na plus and Mg plus, like both mono ionic, wait, I don't know, mono and ionic, never mind, so they're both mono charge, right? And you want to have to compare the two, then you have to imagine sodium as neon and magnesium as sodium, so you have to compare it in that sense, which is a very different from comparing sodium and magnesium itself. So likewise, you should be a bit aware of what you're looking at when you do your explanation, what exactly you're comparing, see whether there's any exceptions in that comparison, or if it's just the usual trend. If the usual trend, then just proceed as normal. If it's a bit different, or if you see there's some problem, then you can look at that and use that in your explanation. And of course, there's a lot of explanations for transition metals as well. um yeah, there's I know there's a lot of different explanation for that, because the transition metals are a very special group, I guess, special indeed. And since they're all in the d orbital, it's a huge group to be having the same orbital in a sense, and therefore the shielding effect is pretty consistent throughout the group, and as well as the increase in charge. For some reason, like they tend to have similar ionic and ionization energy for the same period in the sense. Yeah, so just go and read your notes for the full explanation on that, or if you wait until next year, you may get a video on it. I'm sorry, I don't have a chemistry series. I only have the practical one. Yeah, I can't do everything. I'm also a busy person. But anyways, yeah, so that's how you deal with all the explanation questions and stuff like that. And for organic chemistry, yeah, I do realize a lot of people have trouble with organic chemistry because they can memorize it or whatever. But once again, if you understood organic chemistry, then you don't need to memorize it. You know it by heart. Okay, just kidding. I still needed to memorize organic chemistry, but at least try to understand some of the things so that you'd have lesser things to memorize. You know what I mean? Yeah. So at least for the explanations and all that, you should try to get it through understanding rather than memorization, so that you can save your memorization for stuff that you can get 1 mark easily for, like the conditions of the reaction and stuff like that. And even for some of the conditions, you can kind of theorize technically what should be used. Like if you look at the thing that's to be added, if it's a nitrate group, then well, what do you put in? Use nitric acid because you need that group from the nitric acid. And then you use another acid so that the thing is properly acidified in the sense. Um, and likewise for whatever group that you're adding, you should think of what will actually give you the group. Yeah, so use strategies like this to help you remember your organic chem or your explanations or whatever it is that you need to remember. And finally, I will talk about the booklet, the data booklet. You should be definitely very happy that you get a data booklet. It is really a very useful source in the paper. So what do you do with it? So of course you'll be checking to see if there's any pencil marks in it, but maybe if you wanna be extra sure of where everything is, you can do that. You can do it as you check which page is which thing. But I don't think you need to be that extra about it. You should probably be very familiar with it by now anyways. So once the paper starts, you can open up that booklet to the page that you think you'll be using the most, which I think sometimes would be the electric potential page. I do remember going there many times for your echem stuff, the electropotential stuff, and also for the equations in general. And the other place you'll be visiting a lot is the table that I mentioned earlier, the one with the sizes. And apart from that, it's usually just the periodic table. So, yeah, I can choose one of those places to turn your book to. So it's a bit less trouble when you want to find that particular page again. Yeah, I think that's about it. Good luck for your paper two. I know your I know paper two doesn't have any choices, but you can still do well in it as long as you know how you are doing it, and you have a good strategy. If there's a question that you don't know how to do, you just do it at the end, or you go and do the questions that you're very good at first, finish up all the explanations very quickly, and then move on. But sometimes there might be a question that you kind of know how to do, but at the same time you're not entirely sure. So in that scenario, you can choose to do the question first. Just do it with whatever information that comes to your mind first. And then later on, when you're checking again, you can choose to either update it or just leave it as it is. Because sometimes, if you forget about it, you may end up not having time to do the question. This isn't really maths paper, so you may not really have enough time to finish the questions by the end of the paper if you skip them earlier on. So it would be better to do the questions in this scenario. Unless you really do not know how to do it, then don't bother doing it, I guess. Yeah, but don't panic over the questions that you can do, and also don't think about the previous papers or whatever when you're doing this. Yeah, just do it. Concentrate on this one paper. So with that, I have nothing else left to say. If you have any questions or anything, you can ask me in the comments below. With that, I would like to say thank you and bye. Well, good luck for your paper. If you want, you can subscribe.